So for this question here, if I have 7x plus e to the 6x over 6x plus e to the 7x, and they were asking me to find the horizontal asymptotes of this. Remember, what we're basically doing is doing the limit as x approaches negative infinity, and then we'll do it again. Here, let me just do a little, let me be lazy here. Then we'll do it again, but then we'll say x is approaching positive infinity. So with the left-hand limit, the right-hand limit, right? So for the left-hand limit, I don't even think we need calculus for this. I think we can do this with what we know from pre-algebra or pre-calculus. Let's drop in a big negative number. So, and I'm just gonna say a very negative number. So it's a large negative number. So it's not large, I guess it's small, but it's really distant from 0. Times e to the negative big number over 6 times that negative big number plus e to the negative big number. Well, actually, let's go 6, negative 6 times. Actually, we'll just leave it. I don't even think I need to worry about that on this case. Yeah, let me not worry about that. So e to a number being raised to, or a value being raised to a negative number means you can take the reciprocal, right? So I'm going to have -7 times that big negative number plus 1 over e to that negative, number, whatever that number it is, no longer negative, sorry. And then the same thing with the 6 times that negative number, big, it's the same number as the numerator, so over 1 over another e to some big number, not necessarily the same here, but because 1 is raised to the 6th power, 1's raised to the 7th power, but as that value gets very large, this basically becomes e1 over infinity, which goes to 0. It's not infinity because that's an indeterminate form, but that as 1 over a big number, that goes to 0. So that means this becomes 0, this becomes 0, and if I have the same number, can't I just simplify that fraction? So the horizontal asymptote is y equals 7 over 6. At least that's what I think it is. Makes sense. Now on the right, that doesn't happen. We're still going to get, basically we're going to get infinity plus another number over, which is another infinity number, which is an infinity, right? And same thing with the denominator. Now this is an infinity over infinity, so we can apply L'Hopital's rule to that. So if I apply L'Hopital's rule to that, I get 7 plus e to some big number, right? Actually, is in 6e to the 6x, but I got to take the derivative, sorry. 6 plus 7e to the 7x, okay? So then what do? We do, I'm still getting, at this point, if I substitute in a large number, right, I'm still going to get 7 plus a large number over 6 plus a large number. So why don't we just take L'Hopital's? So that's still infinity over infinity. So let's just take L'Hopital's rule again, or take the derivative again, see if we can apply L'Hopital's rule to get rid of the, so 6e to the 6x becomes 36e to the 6x, and that becomes 7 times 7 again, so 49 e to the 7x, and then I've just got like bases, so doesn't that tell me I can just take and subtract the exponents? So I'm just back to algebra 1, algebra 2 kind of things, college algebra kind of things. So isn't that e to the negative x, which is e to the x in the denominator? And as x goes to infinity now, so now I'm back to taking the limit as x approaches infinity, that's going to give me 36 over a big number, which goes to 0. So I think the right-hand horizontal asymptote is y equals 0. So now let's go to Desmos and see what we have. Let's see here. And lo and behold, look at that, huh? There's out to the left at 7, 6, out to the right, it goes to 0. So I guess I was right.